Texas, and I'm going to have Professor Bill Cooper from our Department of Biology do the formal invitation. Bill, you do that.
No, I don't need
Don't do the mic either. Oops. Battery.
I actually prepared some written comments because Dr. Pianka has so many accomplishments that I can't remember them all. So, yeah, can somebody give me a little light back there? Yeah, okay. I'll manage it. There's a light right here. Okay, Dr. Pianka comes to us from the University of Texas at Austin, as Mark Whitman just told you, where he is the Denton A. Cooley Centennial Professor, which is quite a nice deal, apparently. It gives him a lot of travel money that enables him to spend extended periods in Australia. He's spent about 6 years or more doing field work, a lot of field work in the outback, and he is one of the top ecologists in the country today. I'll tell you a little about his educational background. On his website, I've discovered that he spent the coldest years of his life at Carleton College in Minnesota. And after that, where he got his BA, he went to the University of Washington for a PhD and then to Princeton for a postdoc with Robert MacArthur, who was the leader of a theoretical ecological school that transformed our way of thinking about a lot of things. And he maintains a lot of different interests in the field of ecology, evolutionary biology, both empirical or observational sorts of things, and he's done some important theoretical work as well. Now, I didn't get to ask about this, but I also noted that Dr. Pianka got a DSc from the University of Western Australia, and if somebody wants to ask him about that at the end of the talk, I would like to know how that came about, because that was long after his postdoc. That was the end of his formal education, as far as I can tell. He's received lots of honors. Of course, he has his main professorship that I mentioned earlier. This year, he was named the Distinguished Herpetologist for 2004 by the Herpetologist League. A symposium in his honor was given in Norman, Oklahoma, at the annual meeting of the American Society of Ichthyologists and Herpetologists. He was a Guggenheim Fellow, a Fulbright Senior Research Fellow, and he has entries in almost all of the major who's who sorts of publications. And all of these honors are based on his research. But he also received from the University of Texas an award for teaching excellence. So he's well-rounded as a professor. So why did he get all these honors? He's published over 150 papers in scientific journals and chapters in books. And among these are several citation classics. To be qualified as a citation classic, a paper has to be cited at least 400 times, I think is the current number. Most papers may be cited once or a few times, maybe not even at all. So something that's been published or cited 400 times has had a lot of influence. He has either authored or edited 6 books. several on the ecology and natural history of lizards. Also an autobiography called The Lizard Man Speaks. It's a very interesting book. And he's written a textbook, Evolutionary Ecology, that's gone through 6 editions, been translated into 4 languages, is being translated into 3 more. And it's the most conceptually oriented of the ecology text. It doesn't have a lot of details, but it gives you the important ideas concisely. And I was telling Dr. Pianka that I've never used it in a class, but I've stolen a lot of material from it. That's good for lectures.
Royalties for you.
Dr. Pianka has had many graduate students over the years, and a fair number of them have become distinguished in their own life. So he has contributed to the education of the next generations of biologists. Dr. Pianka has also had a very interesting life, and I recommend this book, Lizard Man Speaks, to you if you're interested in it. I wasn't supposed to be a shill for his book sales, but I thought, why not? This Lizard Man Speaks is a very interesting autobiography, and one of the most striking things that you'll notice early in the book is that at the age of 13, he managed to almost blow his leg off with a bazooka shell. Unfortunately, he made a great find of one that had been left behind and was still live, was thought to be inactivated. I mentioned that he spent a lot of time in the field. He's done extensive field work in the southwestern United States, in the Kalahari Desert, in southern Africa, and in Australia. He currently lives on a ranch outside Austin where he has a small herd of buffalo. And I expect that there is a lot more that I don't know about that's of interest, but if you want to find out what Dr. Pianka thinks, I don't mean to take all your time, sorry about this. What Dr. Pianka really thinks about his life, you can find his obituary on his website. Here you go. And this is his most recent book on monitor lizards. If you're interested in those, you can buy it on Amazon.com.
Thank you, Bill. Thanks a lot. I hope that sells lots of books. Thank you, Dean, for inviting me to give this lecture, and thank you for attending. I want to talk tonight about a real serious problem that has to do with human overpopulation and our rape of this earth. And this all goes back to Henry David Thoreau, if any of you remember Walden. He lived out in the country and talked about civil disobedience. And he wasn't really much of a follower. He was a very independent person. He really, really enjoyed natural history and wilderness. Back in the 1800s, if Thoreau were around today, he would be spinning in his grave, weeping about the state of the earth. Now, he coined the term the book of life and sort of made an analogy with the living creatures on earth as being a book. But it was carried further by other people, especially by a philosopher of biology at the University of Colorado named Holmes Rolston III. Holmes Rolston was the one that attached the vanishing to the book of life. Holmes Rolston wrote a very influential paper in bioscience about 20 years ago called Duties to Endangered Species, where he pled with humans to recognize that other species have a right to exist on this planet too. And that means all other species that evolved on this earth. More than just the vanishing book of life, I'm going to ask questions today, like, will we be able to read it? The Book of Life on Earth it's not just a book. It's not just an encyclopedia. It's a Library of Congress. And I want to take these analogies that Thoreau and Holmes Rolston did a lot further. A page in the Book of Life describes a species. It tells you what it's related to, what it descended from, what it eats, who its predators are, where it lives, how it copes with its physical environment, how it gets through winters, all of these things, its geographic range. The pages are put together in the Book of Life in chapters, and these chapters represent the biomes, the places where animals and plants and microbes live. If you read the whole chapter, you would have some kind of an understanding of how everything in a particular biome interacts with everything else, and you would understand the ecology of that biome. But also, you would know a lot about the evolution of all the components and how this biome came to be as it is. Now, the Book of Life is written in a language that we can hardly read. Humans have been trying to study life on Earth for a long time, and we know a little. We can decipher some of it, but we're only now beginning to get the tools to really, really read some of the intricate details. And it's a very sad state that we have to, as we're getting the tools to read the book is tattered and torn. Whole pages are missing where we've driven species extinct. Whole chapters have been ripped out, like the tall grass prairies, where there were prairie dogs and black-faced ferrets and American bison. We'll never be able to read those chapters because they're gone. We destroyed them before we had a chance to read them. And this is too bad. So one of the questions is can we read it? Do we have the vocabulary and the tools to read it? Another is, will we be allowed to try to read it? I'm finding, as a biologist, I've only been a biologist for about 40 or 50 years, that it's getting increasingly more and more difficult to study vertebrates, lizards, because we've taken away so much habitat, so many species are so limited in numbers and in trouble that now we have all kinds of guardian committees and laws, and you have to get permission to do things and go through animal welfare committees and this and that and the other thing, things that we didn't have to do before we took away so much habitat. So now it's getting to where there are laws preventing biologists from studying organisms. In Australia, just recently, the animal welfare committees decided that it was no longer a good idea to let biologists toe clip lizards to identify them as individuals. This has been a standard technique in lizard biology for 50 years, and now we can't use it anymore. They've decided toe clipping is politically incorrect. And then the other question is, are we going to have enough time? We are really running out of time on this earth. And even though we have the tools we need now to begin to read this Vanishing book, we probably don't have time enough, even if we were allowed to do it. Now, one of the biggest problems I see on this earth is anthropocentrism. Is the arrogant attitude humans have that everything on this earth was put here for us to use as we see fit. When I see somebody cut down an ancient century-old tree, I just think of the audacity of a little man with a chainsaw with a 24-inch bar. You can take a tree down in no time, or with a bulldozer. But it took a tree a long time to get to be several hundred years old. We see ourselves at the center of the universe. We think everything that's there was put there for us to use. When I hear people say things like, "What good are rattlesnakes?" it really annoys me. Rattlesnakes were here long before humans. They're part of the natural ecology. They have as much right to this earth as we do. And yet every rattlesnake that runs into a human is killed. And I see them disappearing. One of my neighbors made the mistake of asking me once over the back fence when I first was introducing myself to her. She said, "What good are lizards?" Oh, she shouldn't have said that. I just looked her in the eye and I said, "What good are you?" I haven't had much contact with her since. Now, what good are rattlesnakes? What good are lizards? I'm an ecologist. Ecologists study animals and plants and microbes in their natural environments, in the pristine places where they evolved. We're interested in how they interact with other organisms and how they cope and how they persist and stay on this planet. I get phone calls all the time from people who want to see a rattlesnake. And they want to see a rattlesnake behind glass, in a cage. They don't want to see a wild rattlesnake crawling around or in their face. One time, I was pleading with some farmers in Texas not to kill the rattlesnakes around their place. And the woman looked at me like I was absolutely wacko and said, "I don't know how you feel about zoos." On my way home, I was thinking about it. And I thought, what's wrong with a rattlesnake in a zoo? And then it hit me. It's dead. It's out of context. It's like if you took a D.H. Lawrence novel and cut the word love out and put it in a little glass jar. You don't know if it's a noun. You don't know if it's a verb. You don't know who loves who. A rattlesnake in a cage doesn't have any natural history. It doesn't have any ecology. It's completely out of context. And from an ecologist's point of view, it might as well be dead because it doesn't have a pristine natural environment in which it evolved where it makes sense to be a rattlesnake. Without pristine natural habitats where plants and animals and microbes are living the way they did through the eons in which they evolved on this planet, we won't be able to understand their ecology. We won't be able to read the Vanishing Book of Life. There's Thoreau. I mentioned that pages and chapter are gone, I hope passionately, so that you can appreciate how deeply I feel about this. And unfortunately, pristine natural systems are becoming very, very hard to find. The influence of humans on this planet is so pervasive that we can't get away from human disturbance. The atmosphere around the planet is disturbed. Water everywhere is polluted. We've taken over vast amounts of habitat. Current estimates are that humans are using half of the land surface of the earth. That means we've taken away half of the habitat of everything else. We're using more than half of the fresh water on the earth, and most of that is polluted. And freshwater fish and amphibians worldwide are endangered and threatened with extinction because of our inane activities and our population growth, our rapacious management of this planet. Now, we have to try to save the Vanishing Book of Life before it's gone. And that's the science of conservation biology, which is applied ecology. And that's what I'm going to talk about mostly today. But I also want to stress, as much as I possibly can, how important it is to try to read it. Because as humans, we want to understand the world that we live in. And we should be curious about it. And we need to read this book to understand our place on this planet. And being arrogant and anthropocentric is not getting us there. We're not informed. It's incredible to me that in 2004 we know as little about ecological systems, communities, as we do. We haven't put the resources down to study them. In fact, we've done just the opposite. Here's a picture of Holmes Rolston. He said, "Destroying species is like tearing pages out of an unread book, written in a language humans hardly know how to read. He made the case again and again that other organisms have an ethical right to exist, and that we do not have a right to destroy them and make them go extinct prematurely. Now, here's some of the tools we have. I get very excited when I look at this list. We can go anywhere around the earth in days. We can email anywhere around the earth in instants. We can get emails back from Australia in 5 minutes. We're connected. When I first saw faxes, I couldn't believe it. I was in Australia running a fax through a machine, and it was coming out. I could see it in my head. Halfway around the world in Texas, it was coming out of a fax machine. The exact piece of paper, or copy of it, that I sent in there, it was coming out. I didn't mention Ethernet. That should be on here. Email, I guess. It's so fantastic now. You can have a colleague on the other side of the world, as I do in Australia, and then I can be working all day long on a manuscript or some research we're doing, and at the end of the day, before I go home, I email it to him, and then I go to sleep, and he works on it around the clock in the other hemisphere, and it's waiting for me when I get back to work the next day. We can make incredible progress with this kind of technology. We have fancy things like geographic information systems that allow us to overlay spatial things like distributions of organisms, where you catch which species on a landscape, and analyze how the habitat affects the distribution of species. And you can do this at different scales. We have satellite imagery, which is like an eye in the sky that takes pictures of landscapes. Incredible stuff that we've never had before. Global positioning systems. I wish they had put those satellites up there with the GPS coordinates before I went out and collected all the lizards and did all the work I've done, because all I have are my estimates, like 5 miles from Mojave, California, on highway so-and-so east, and that's not as good as an accurate latitude and longitude. The GPS system didn't come along soon enough. For molecular systematics, for recovering the relatedness of species and who's a sister to who and what the common ancestors are, there's no substitute for DNA sequencing, which is made possible by this amazing discovery that you can amplify DNA with the polymerase chain reaction. You can take a little tiny bit of DNA and make a test tube full of it, or a room full of it if you want it, and then you can sequence it. And some of those sequences provide us with what we think is a very accurate signal of phylogenetic history that could go back for millions of years in some cases. And now I want to talk about our computers. We're taking them for granted, but the computers we have today are extremely powerful, sophisticated machines that enable us to do things you couldn't have dreamt of. Students today don't remember what it was like to have a typewriter and how precious a clean draft was. It's just too easy now. It's the same way with figures. You used to have to get out the Leroy set or the rub-on lettering, and it was making your figures to illustrate your papers that kept you from making progress. Now you can generate figures all you want. There's all kinds of programs that make graphs for you. Graph papers disappeared. It used to be precious stuff that you hid from people. And now I see it out in the hall being used for trash, giveaway stuff. Some of the software we have today is so imaginative and powerful, I can hardly believe it. I'm just going to mention one, and that's a program David Swaffer's written called POWER. And it does some fantastic things in terms of recovering phylogenies from DNA sequences. So we've got all these powerful tools, but the book of life is disappearing right under our eyes. Conservation biology is a crisis discipline. It's like surgery is to physiology, like war is to politics. And it's an emergency. It's an emergency. It's a man-made emergency. We've got to do better by the other critters that live on this earth. And by that I mean plants, microbes, and animals. Conservation biology is applied ecology. It's a gap. It bridges the gap between the natural sciences and the social sciences. And it involves considerations that we can call ethics, ethical biology. Some of the things conservation biologists concern themselves with are recognizing, identifying, and managing endangered species, getting them listed. Now, I don't know how much longer the Endangered Species Act will last. There's a lot of people out there that are ready to give it up. Hell with the darters, build the dam, right? What good are they? That's this anthropocentric attitude, and I detest it. Conservation biologists are also interested in making nature reserves that work, that keep species from going extinct, so that we can keep some of these pages a little bit longer. And I think the reason for keeping the pages, in addition to the ethical reason that we have no right to abolish other species, is partly so that we can read those pages and understand our world, the world that we dominate. Conservation biologists are also trying to do things like restore vanishing ecosystems. This turns out to be much, much more difficult than you might think. You can't just build a prairie without having some prairie. If you don't have all the pieces, you can't put the puzzle together. Conservation biologists are also all involved in trying to save ecosystems, especially ones that are threatened. And they talk about environmental ethics, and some of them are getting very involved in economics. Now here I wanted to show you some of the very important parts of the world in green and red. The green is the tropical rainforests of the world, which are distributed pretty much on the equator, or both sides of it. And the red, with very small areas there, are what are called hotspots. These are places where there's a high diversity of endemic species that are only found in these little areas that are red. And if we could save those tiny little spots there, it's less than 2% of the Earth's surface, land surface. We could save practically 50% of the species on Earth. But unfortunately, those hotspots, especially the ones in Southeast Asia, are places where third world countries are overpopulating and people are living at a very low standard, and they're raping their natural resources as fast as they can in an effort to catch up with the rest of us. When I was a boy, probably about 7, 8, 9, my favorite book was Audubon's Birds of the World, big fat book that we had in the house, and I used to sit and look at it for hours. And I remember looking at this picture especially. The last passenger pigeon. She died in the Cincinnati Zoo in 1914. I couldn't believe it. I read about the flocks that darkened the skies. I read about beating these things to death and putting them in barrels and pickles and shipping them around the world. I couldn't believe it. We just erased this thing. And I sat there and I looked at it and I thought, even then, as a little kid, it can't be gone. It can't be gone for good. We should be able to bring it back. And I saw pictures of other doves that looked like it. And I thought, maybe someday we could bring it back. Well, technology is getting there. There's bird skins of passenger pigeons in museums. They have DNA in them. And we're getting closer and closer all the time to reconstructing some of these extinct things. if we make it another century, we might be able to see a passenger pigeon again, and not just the skin of a dead museum specimen. Some of the things that are hurting the most: rhinos. Just in the last 50 years, rhinos have gone to the brink because of this silly notion that their horns are an aphrodisiac that help humans enjoy sex. Poor Africans that have no chance of ever making it can make enough money if they poach a rhino to be rich and successful for the rest of their lives. And you can get young men to go out to get a rhino by just giving them a gun and the promise of $1,000. It's so bad. The gray in these is the original geographic distribution, and the black is where you can still find them. And you have to look very hard to find the black in some of these. It's so bad that rhinos in some areas are under 24-hour armed guard, and poachers are shot on sight. So the relative value of a human and a wild animal have changed drastically as we've destroyed the wild animals. And the wild animals are now under protection. And I would say they're under too much protection when biologists are no longer allowed to study them. I've got this herd of bison, and I really enjoy them. Cows are boring. Bison are very interesting animals. I don't get tired of looking at my bison. Here's what we did to them. They once ranged all across the Great Plains, well down into Mexico. You can see the range before 1800 is the outermost, lightest one. About 1850, we had knocked their range back quite a bit, and then they put the Union Pacific Railroad line through, and that's when people started shooting them from the train. You just sat on a railroad car with a big high caliber gun and shot bison as you went across the plains. And they chopped the herd in half, so there was a northern herd and a southern herd. General Sheridan said at the time that the people that shot the bison did more to eradicate the American Indians than all the cavalry could ever have done. We starved them out in addition to eradicating them with smallpox and other things. So now American bison are not really threatened, but there's only a few really wild herds. Here's some of my animals. The bottom left there is my herd bull, Lucifer. He stands 6 feet high at the hump, and he weighs a ton, and he clears a 4-foot fence. He just mashes the barbed wire down and goes over. And the earth must shudder when that ton comes down on the other side. I think it might go backwards for a millisecond. Here's an excerpt from Ray Bradbury's Dandelion Wine. I'm not going to read it, but basically, people that saw the bison herds were just dumbfounded, awestruck, because these animals were almost limitless. There were millions and millions of them. Herds roared past, day and night sometimes. One big continuous herd, and the earth shook. It was like a thunder shower, but it was bison. And that, unfortunately, is sort of gone now. An hour, 3 hours, 6, it took the storm, that's the bison herd, to pass away over the horizon towards less kind men than me. I stood alone, stone deaf, and walked numb through a town 100 miles south and heard not the voices of men, and I was satisfied not to hear. For a little while I wanted to remember the thunder. I hear it still on summer afternoons, when the rain shakes over the lake. I wish you could have heard it. These things are gone, and they're not coming back. So, one of the anthropocentric focal points is, what good is all this biodiversity? Why do we need it? What good is a rattlesnake? What good is a lizard? What good is a whooping crane? Why do they matter? Well, anthropocentric answers are out there. We are enriched by lizards. Our life would be impoverished without them. The same goes for rattlesnakes. There's all kinds of molecules that plants and animals have evolved that are very, very useful to us. Natural selection has invented painkillers, antibiotics, analgesics, all kinds of things. A few years back, they discovered in the bark of a Pacific yew plant a chemical they named Taxol that was very useful in fighting certain kinds of ovarian cancers. But for a long time, they were out killing every yew plant they could get to send its bark to a factory to get the Taxol out of it. That was tough on the yew plants. But the organic chemists came to our rescue and figured out how to synthesize that molecule, and so now the yew plants are recovering. The point is that natural selection has invented all kinds of things, and we've barely begun to sample them, and a lot of them are disappearing before our eyes. Conservation biologists have a big debate they call the Schloss debate. That stands for single large or several small. And the debate is all about how to set up nature reserves. Should you have one great big reserve or several smaller reserves? And the problem is, if you have one great big reserve, and there's some kind of a epidemic of a parasite or something, it could sweep through and knock your species out in the one big reserve. But if you have several small reserves, even though that each would be more vulnerable to an extinction event, you would have some backup, and you could re-inoculate. So that's the basis of that, and that's part of the whole challenge of designing nature reserves, which is not an easy thing to do when humans are competing with animals for every square inch of this planet. Another thing they're worried about is how small can a population get before it's going to go extinct. And they try to make estimates of what they call minimum viable population size. By viable, we mean the plants or animals can reproduce and continue to persist and not go extinct in the immediate future. A lot of populations have been small long enough, they've gone through a genetic bottleneck, and genes have become fixed, and there's not much genetic variability left. And we're worried that because of this, things like cheetahs and black-faced ferrets might already be extinct for all practical purposes because their genetic variability is gone because they've been squozing through a small population size for too long. Population viability analysis is a lot like minimum viable population size. It's interesting, you've all heard about the spotted owl on the west that used to be a denizen of the old growth forest. We cut down almost all of the old growth forest across all of America, and there's only like a small fraction of like 4 or 5% of old growth left, and the loggers want to cut that. But that's the habitat of the spotted owl. And the population viability analysis that have been done on things like the spotted owl and the grizzly bear, by and large, say that it's already too late. Their populations aren't viable. They've been insulted to the point where they cannot make it. There's a sensitive technique of looking at population viability analysis that involves what are called Leslie matrices, and these have survivorship and fecundities in them, and they talk about different age classes. And sometimes with this kind of approach, you can actually identify which age classes you need to protect to keep the species in existence. And it might be that saving adults is important, but it might be that increasing the survivorship of the juveniles is important. If you can identify that with a mathematical analysis, then you can take appropriate management decisions to try to save it. One conservation biologist, Michael Soleil, coined the phrase the extinction vortex. And this is like a whirlpool. He says that the extinction vortex is sucking species to extinction. And the extinction vortex is a result of a lot of things. Probably the most important is habitat loss, but also fragmentation of habitats, breaking them up into smaller patches. Small population size is also a factor because of this genetic bottleneck and random walks to extinction as you get very small. If you have 5 deaths and they're followed by one birth, the population diminishes by 4. Habitat fragmentation, I mentioned that. Genetic and demographic stochasticity, they're sort of sophisticated terms that refer to chancy events, and demographic stochasticity is this random walk to extinction aspect. Pollution and climate change. We have insulted the atmosphere to the point that the climate of Earth has changed. The deep oceans are degrees warmer now than they've ever been. This is having drastic, widespread consequences on everything. Geographic ranges of butterflies and birds are moving, shifting in response to what we've done to the climate on Earth. We've been very lucky so far because we're walking a knife edge. And for a long time, we stood on the edge of that razor blade and didn't fall off. And that was because the increased particulate matter we were putting in the atmosphere cut down incident solar radiation at the same time that we held more heat in with the increased greenhouse effect, and they balanced each other out. But now we've fallen off of the razor blade, and it's getting warmer. And it's going to get warmer and warmer. Deforestation. All over the earth, humans have cut down trees. And we've been doing it for a long time to burn them for our own heat. This is Madagascar, which is a very, very special place with lots and lots of endemics that are found only on Madagascar. It's been isolated from mainland Africa for 100 million years. And it's got some very fantastic animals on it. I just show you 2 of its lizards there. A little tiny dwarf chameleon, Brachysia stumphii. Try to find one of those in dead leaves. Herpetologists step on them and squash them and wish they hadn't. Zonosaurus butgeri, only known from a handful of specimens. These are Madagascar critters, and there's lots more than just those 2. You can see the original extent of forest in Madagascar on the eastern side was pretty broad, and by 1985 it had been cut to less than a third. I would imagine if I had a 2004 map, there'd be virtually no forest left. So this is one of our problems. Oh, I always have to remember to tell people here about a place in the Sahara. It was an oasis left over from the Pleistocene, and there were 3 trees there, and an oasis with water. And on the map of the Sahara, it's 150, 200 miles to anything else. In Arabic, it said 3 trees, tres árboles. Somebody cut them down just to keep warm one night. There's no trees there anymore. I wish I could track down the origin of this. If anybody knows who said it, please tell me. Once we were surrounded by wilderness and wild animals, but now we surround them. This is a very famous square mile in Wisconsin, taken across just a little over a century, from 1831 when we first got there. It was almost entirely forested with a little bit of prairie in the southwestern corner. And you can see what we did in the first 50 years. We cleared a lot of the forest and left little patches behind. And in the next 20 years, we cleared even more. And then by 1950, the landscape looks about like what it looks like when you look down from an airplane flying over Indiana today. Little tiny woodlots. We haven't left much for anything else. Fragmentation of habitats has a really savage effect on some species. Small songbirds like warblers are particularly vulnerable and hit badly by this because brood parasites, cowbirds, are birds of the edge where prairie meets forest. In the 1800s, cowbirds must have been very rare, and the small songbirds had extensive patches of forest they could nest in and escape from songbird predation or cowbird predation. Nest parasitism. Basically, a cowbird lays an egg in your nest and you raise it cowbird instead of your own chick. Well, that's pretty detrimental if you don't raise your own chicks and you raise cowbirds. Well, now we have lots and lots of cowbirds because we have a lot of edge. And small songbirds don't have much core habitat, that little bit in the interior you see there, to lay their eggs in where they're safe from the cowbirds. So this is just one of the ways that habitat fragmentation has. This is the scariest graph there is. This is unbelievable. Just sit and think about it. How long ago was it we passed 6 billion? We're now almost at 6.5. Another 5 years will be 7. All we can hope for is that AIDS epidemic kills a lot of Africans. They've all got it. Or even better, that Ebola mutates to be airborne and there's a massive epidemic around the planet, killing 90% of us and knocking us back to a population density that's reasonable. Be fruitful and multiply and subdue the earth. Organized religion is the enemy, man. They have painted the path to get where we are. There it is. And we didn't replenish the earth. We checked off all the others. We have dominion over the fish and the fowl. We've subdued it. We've taken it. But we haven't replenished anything. We're not taking good care of it. This guy was a cartoonist at Texas, and he went on to national fame. Hope you enjoy your meat. Look, he's wearing leather shoes. There goes another rainforest assassin, polluter. Look at him standing there spewing out CO2. We're all responsible. Everything we do. Every time you fill up your gas tank, every time you flush your toilet, every time you buy a new gizmo for your computer, or a new telephone, or a cell phone, you're contributing to all of this. None of us are innocent. This is a place in New Guinea that happened to have gold and copper on the top of that mountain. But most of it's been removed here. And I show this because Freeport-McMoRan is a Texas-based company in Houston that has worked worldwide to get as rich as it can. And this is a massive mining operation. See these slurries running down the side of the mountain that look like mud? That's actually human disturbance that's making that. And when it rains, and it rains a lot in New Guinea, that mud slides down and goes into places that were once pristine, beautiful rivers flowing through pristine habitat where primitive peoples used to live. And now they're mud clogged and it's a mess. Freeport-McMoRan officials were in bed with the Indonesian officials and practiced genocide on some of the primitive peoples that were in their way. They were against all of this, quote, development of their island. And they have a slurry tube that's about 1 meter or 2 in diameter that goes down the side of the mountain to a port where they send the copper and gold ore down to big ships that haul it off to be refined. At one point, the natives managed to get a hold of some dynamite from the miners themselves, and they blew up this slurry tube. And I heard a Freeport-McMoRan official complaining about it, saying that it cost them $1 million a day to have that down. So they're raping this mountaintop in Indonesia for $300 million a year. And this is continuing. This is Southeast Asia, on Borneo, I think, showing the clear cutting that's going on. And that wood is being sold around the world. When you buy some wood, you're contributing to this kind of thing. When you buy wood products that are made from wood, it's taken out of places like this. Now this is wholesale habitat destruction. None of the things that lived in that undisturbed forest are going to live out in that deforested clear-cut area. So now I come back to a land ethic. And one of the greatest conservationists that ever lived, Aldo Leopold. He died in the 50s. He wrote a book which everyone should read called the Sam County Almanac. It's actually a collection of little short stories that he wrote over a period of decades. And it's a very telling book. And I'll be surprised if you read it if it doesn't bring you to tears. It did to me again and again. Now, what Leopold says is that there's an ethical sequence. And we all place ourselves in our own selfish way at the center of this. Everything revolves around me. And that's the bottom, right? That's the narrowest perspective you can have on the world, is to be a selfish person that only thinks about yourself. And of course, we encourage people not to be quite so selfish. It's nice to be nice to your kin. Maybe help your kids through college. Help your aunt when she's sick. That kind of thing. When we were cavemen, and that wasn't so long ago, 20,000 years ago, we were essentially cavemen and women. We had small groups. And a group about this size would live together in a cave, but they'd be related in various ways. Every person in that group would have a function, and we'd sit around in the winter around a campfire telling stories about how we survived the bad winters 10 years ago and pass on a culture. Cavemen were pretty smart, and they managed to do a lot. Now, extending beyond a little group like that, we have our own race, our own nation. We're very patriotic and very pro-American, okay? And there's factions within America, religious factions. Then we could try to extend it out a little bit to people of other races, okay? Other nations, other regions. How do we feel about Iraqis, Iranians, North Koreans? Things get more and more tenuous as you spread out from the self. Now, individuals with other sentient animals. I'm thinking here of chimpanzees, gorillas, orangutans, and even some lizards, okay? Some lizards are smart enough to recognize individual people. Some lizards can count. Even snakes can recognize individuals and behave accordingly. So there's other sentient animals out there, and sentient. My bison are like that. Let me just give you one story. I've named a few of them, which is probably a mistake, because then you can never sacrifice them or harvest them. But they know their names. One time I was standing at the fence, and a cow came out of the bushes towards me. And I looked at her and I said, "Oh, hi, old cow. Where's Big Boy?" She looked over one shoulder, and Big Boy stepped out of the bushes. And I said, "Where's Geneva?" She looked over the other shoulder, and Geneva stepped out of the bushes. She's as smart as any dog. She knew what I was saying. She knew their names. She understood what I was telling her, asking her. Now, what Leopold would like us to do would extend our attitude about ourselves and our family groups all the way out to other species. All other species, even scorpions, okay, and rattlesnakes, and the whole earth, the ecosystem. So he says the land ethic he's defined changes the role of humans from a conqueror to a mere member. We have to be stewards of this planet. We have to respect other species, and we have to take care of this earth. It wasn't put here for us to take. We have to leave something behind. Ideally, we would leave a planet behind that's even better than the one we came into. We're a far cry from doing this. Our economy is upside down. It's based on a flawed scheme of chain letter, Ponzi growth. Grow. We can't. We have to reinvent an economy, an equilibrium economy, an economy where you grow your own food and ride a bicycle and earn what you get with your own two hands. We have to uninvent money It's not going to be easy. It's not going to be easy at all to solve the problems that we've raced headlong into. And we're so far along on the upshoot and the exponential growth that I fear there's no hope. I really don't see politicians addressing overpopulation. It's just not going to win an election. So it's ignored. Now I just wanted to end with a couple of cool examples of what my student Brian Jennings and I have done that we think is neat using some of this modern technology. Brian's a postdoc now at Harvard, and when he was a grad student of mine, we spent a lot of time in Australia collecting these legless geckos called pygopodids. There's 3 examples of them there. They look like snakes, but they're actually geckos. And some of them are subterranean, like the one at the top that burrow through the sand. Some of them are nocturnal, like the one in the middle. And some of them are snake-like with very big jaws that eat other lizards, like the one at the bottom. And there's about 30 species. And we got tissues from all of these, sequenced lots and lots of base pairs, including some mitochondrial, a lot of mitochondrial, some nuclear genes. And after a lot of work, we were able to reconstruct a phylogeny, which you can see there at the top on the left. And we were really fortunate because there's a fossil pygopodid that looks very much like the one in the center on the right from Australia that's estimated to be about 23 million years old. It's very clear that it's a pygopus, so we can place it on this branch that leads to Lepidopus and Nigriceps. It's definitely on that branch. And that allows us to calibrate this phylogeny and put a time scale on the bottom. So we can say that roughly 23 million years ago, when that fossil occurred, had to be along that little node between T and V, that little node labeled U, somewhere along there. Then we can use some fancy new software to generate the plot you see at the bottom, which is actually a semi-logarithmic plot. So the vertical axis is a logarithmic axis, estimating the number of lineages through time in this clade, this group of descendants of one common ancestor. If the rate at which new species arose was constant, you would expect a straight line on this graph. But it's not a straight line, it's actually convex upwards. And you'll notice there's a couple of places that we marked, 1 and 2, where there's steep bursts up. And that suggests that things might have happened roughly 20 million years ago and roughly 28 million years ago in Australia that led to more new species faster than you would expect. And another thing about this plot that's interesting is that it seems to be leveling off as we get into the last 10 million years ago. It's just not continuing to increase. Well, we were not quite so lucky in the next one, and we used somebody else's data. Jennifer Ast at the University of Michigan sequenced almost all the species of monitor lizards and came up with a nice little monitor lizard tree, and we could calculate a similar phylogeny for hers and make a similar graph, but we couldn't find a fossil that we could date, so we couldn't actually calibrate the horizontal axis. But you'll notice it's very similar in shape. And monitor lizards are completely different lizards from legless geckos, from pygopodids. But the fact that it has a similar shape suggests to me that we've got 2 observations now that suggest that the rate of speciation in the immediate past was faster and has leveled off towards the recent. And if we could calibrate this one, we might be able to see whether the sudden upsurges in numbers of species occurred at similar times. And that would be interesting because that would suggest that similar events happened in Australia, or the same events happened in Australia that had similar consequences in very different lizards. Now, it could also be that because monitors are very different than pygopodids, those periods of rapid speciation wouldn't be coincident. It'd be really nice, before we lose the Vanishing Book of Life and access to it, to do this for all the other groups of Australian lizards and make similar graphs. And it might just be that we can recover some of the past history of what happened in Australia by looking with modern technological techniques, with DNA sequencing and phylogenies and this fancy software. We might be able to reconstruct the history of Australia millions of years ago. And we can do this for the entire Earth if we had the data from all the different continents and all the different taxa. And I think that's very exciting. Now, this is a kind of a pessimistic way to end this. When I started being a scientist in 1960, I was a kid wet behind the ears, and there was a lot of sand in the hourglass. And in 50 years, less than 50 years, that sand has poured through. And now we don't have much time. I hope I've convinced you to change your lifestyle, start growing plants, ride a bicycle, vote differently. I'll be glad to take any questions. Oh, I'll tell you about the DSC.
Yes.
It's not an honorary degree, it's a Doctor of Science degree. It's in the British tradition. Australia is very much in the British tradition. And it's a degree, it's a doctorate, a degree you get for research that you did. And you don't actually enroll for a PhD program like we do in this country, but you earn it. In order to get my DSC, I had to collate a lot of my published papers and books into a thesis, which was about 4 inches thick, and make 4 copies of it, which they sent out for external review. And it took months, and then they awarded me my DSC. And the only reason I was eligible for it was because of the time I spent at the University of Western Australia when I was a postdoc in 1966 and 67. But then I kept coming back at a regular basis, and they couldn't deny me the right to apply for one. So that's that. Any questions? Yeah.
Well, how do you think you've changed the way you do science given the way what you presented tonight? How's that sort of affected your professional approach to things?
How has this affected what?
Just the way you do science yourself as an individual.
Well, I would say this. When I started off, I didn't think much about phylogenies, but nobody was. And now, the phylogenetic perspective has really infiltrated all of biology. It's so bad that unless you do a proper phylogenetic analysis, you can't get anything published anymore. And so now I embrace phylogenies. I don't do them myself much. I've got a little DNA lab, but I can't find the grant support to do this kind of stuff. I'm not a systematist, I'm an ecologist. But what I really like is what you can do once you have a phylogeny. You can actually try to reconstruct what happened in the evolutionary history of a group. And you can use your extant existing species to infer ancestral states and work your way back. And to me, this is a really powerful way to study evolution. So I'm really interested in phylogenies now, and I wasn't. But I'm still very enamored of lizard ecology and do as much of it as they'll let me. It's getting harder and harder and harder. So I would say that we must try to conserve the vanishing book of life and save as much of it as we can, as long as we can. But we don't do it just for its own. A biological nature reserve is a good thing to have, but it should be accessible to biologists. You can't just exclude them. The reason for saving it is to save the other species, but it's also to read it. I don't get actively involved in conservation biology because I feel like my own intellectual powers should be spent reading it rather than saving it. And anybody can be a tree hugger. But I'm encouraging tree huggers to let us have access to it. That's not really an answer to your question. Yeah?
I'm just kind of curious. Those of us that are from the western part of the world don't want to have the developing nations to have the same standard. How can you convince someone in a developing nation to not, quote, tamper with the environment, whereas we are enjoying the fruit of the labor?
You can't. I mean, that would be hypocritical. We destroyed our tall grass prairies and our bison herds. Why shouldn't they? I mean, you can't tell them what to do. But it's a crisis. And the big problem is that there's a lot of hungry people in Africa and Asia. And, you know, they're going to go out and make turtle soup out of an endangered turtle, whether you call it endangered or not. That's one reason I see the glass is more than half empty. I mean, look at that.
If you believe that, then why do you make blanket statements like saying all we can hope for is that all of the people in Africa will die from AIDS?
Oh, I want more than just that. I want 90% of Americans dead, too. I want Ebola Zaire to be airborne. I want 9 out of 10 people I know dead. And that'll probably include me with probability of 0.9. Not just Africa. I'm just saying the Africans right now have a very serious problem.
Of the earth and say, I want these people dead, I want these people dead. Everybody's contributing. If that was the case, then 100 years ago, everybody would have wanted the Americans dead because we have destroyed North America and we've made problems throughout the world because we're the ones that consume all of these things that are getting destroyed. And all these resources that are getting used up, we're the ones that are benefiting from this.
Well, it's true that anybody in an advanced society like ours, we have like 10, 50 times the impact on Earth's resources as, you know, a poor person in Bangladesh that has nothing and isn't burning any electricity. So in many ways, we are hundreds of times more guilty for everything that's wrong with the Earth. And in fact, America is really bad when it comes to polluting the atmosphere. We refuse to even sign these treaties. I've got to feel sorry for people in Samoa because they're going to be underwater because of what we're doing. And they can't do anything about it. We are actually reckless. We're really lucky that China had a massive famine in 1960. They lost 1 billion people or more. And if they hadn't, we'd have way more than 6.5 billion to contend with now. And if that had happened, China probably wouldn't be as peaceful as it is now. We're also lucky that the International Olympic Committee gave the Games to Beijing in 2008 because that'll keep them behaving themselves. They won't invade Taiwan for another 4 years. History has an unmistakable mark. And just because we happen to be the last superpower doesn't make us good. We're actually very evil. Yeah?
In Leopold's expanding circles and the hope for expansion of conscience.
That was actually drawn by a conservation biologist, not by Aldo Leopold, but it's basically an extension of his land ethic.
The step where you go, well, the last few outward steps have always seemed to me like the real toughies. We go to a local park sometimes and go on nature walks, and there are usually kids on the walks, and they're being told things about caring about what's in the park and trying to learn something about what's there. And I always wonder how much it really takes, how hard that that set of steps is. Do you see any hope for that? Going from individuals, well, even from people, to individuals of other senses.
I don't think we're doing very well at going from our own religious group to another religious group, let alone from our own nation to another nation. I mean, it's pretty obvious the way the world's going. We're not making those transitions. And, you know, when we talk about other sentient animals, I always like to just wonder what it would be like if instead of being the most powerful, dominant life force on Earth, if gorillas or chimps had achieved that, and we were their lab animals. That would be really fitting. It would be really appropriate for humans to have to be held down by some other life form. But I don't know what the answer to your question is. I know that when I was a kid, I grew up really close to wild animals. We could go out the back door and go to a creek, and there were snakes and frogs and fish. And I think that brought me up with an intimate love of natural history. And I don't think kids these days get it because they're urbanized and there's no wilderness anymore for them to really enjoy. And I think that that's a big problem. People have lost track with the essence of where our livelihood comes from. Food is viewed as a commodity that's bought and sold and unlimited. And you're told absolutely insane things, and people believe it. Like, we don't need the wilderness. Pave it over. Build a dam. Pump the oil out. Do this. Do whatever you want. We need that. They've lost track of where food comes from. Most people think Triscuits grow on supermarket shelves. They don't. And you're going to see it when we change the climate enough. And you go to the supermarket and the shelves are empty. And money won't buy you food. And the sooner that happens, the better. Because people are not going to wake up until they're pinched and pinched hard. Now, some people, when I talk like this, say things like, oh, I've heard you doomsday ecologists before. Paul Ehrlich tried to start something like this back in the 60s. He wrote a really impressive little book called The Population Bomb. He was right on the money. But we've managed, to squeak through another 50 years almost. And things are really, really bad now. But the fact that you can still get clean water to drink is one of the things people talk about. Paul talked about how water is going to be in short supply. Water is in short supply. We're going to have real water wars before this is over. People are paying more right now for a jug of water than they're paying for gasoline in some places. Things are bad. You can't just sit back on your haunches and think things are good. Resources aren't ever expanding. The per capita share of everything is shrinking every day. I took the total surface of the land of the earth and divided by 6.5 billion. Comes out to about 5 acres. That's your share. And that includes the Sahara, and Antarctica, and the tall, cold mountains like Everest and Alaska where there's bears walking around. You get 5 acres to live on. That's your share of the earth. And in another 5-10 years, it's less. It'll be 4 acres. I don't think you can live on 4 or 5 acres of a lot of this earth. It's not sustainable. And putting oxymorons together like sustainable development is stupidity. But people do it, especially politicians. I'm sure there's a lot of people out there who disagree with everything I said because you're so anthropocentric. There's so much that everything on this earth is important. It was put here for me. I can have anything I want. You've got to get off of your anthropocentric high horse. Put an HIV virus on that pedestal and ask yourself, if I was an HIV virus, how would I view things? oh boy, I got myself a lot of substrate to grow on. And they're behaving just right. They're moving all over the place. They're social, they're sexual. This is glorious. And I've got it because I don't even start to make them sick for 4 or 5 years. In the meantime, they're infective, spreading me. Ebola kills too fast. It kills 9 out of 10 just instantly, within a week. That's why it doesn't get started and it dies out. But there's a very close relative to Ebola, another virus called Restini, Ebola Restini, from Reston, West Virginia, that kills monkeys and not humans. It came over from Africa too. And it's almost identical in molecular structure to Zaire. It's just a few differences. But it's airborne. It spreads through the air. A monkey sneezes and another monkey that didn't touch him gets it. So Zaire still has potential. Just has to mutate.
I think we have time for one more.
Sure.
This is probably a more philosophical. Do you think that population is a major issue?
Yes, I think population is a major issue. Is that what you asked?
Yeah.
Oh, yeah. It is the most important problem facing humans, and we're not making any real effort to do anything about it. The Chinese saw it coming, and with a powerful government like that, they did something to change their population growth. And that is what's responsible for China coming out of being a third world country. Now China's making the same mistakes we're making. Chinese want to drive Suburbans, and they're burning up a lot of the world's oil, and they're following in our footsteps. And I say it's great. You know, if an American can drive a gas-guzzling hunk that weighs 2 tons like a Ford Expedition down the highway, why can't a Chinaman? We're in for some serious, serious problems here, and soon in your life.